Okay, everybody. So we're going to go through atmospheric carbon dioxide and particulate matter. As you take notes on this, you're essentially going to create an outline and you're going to fill in more information and detail from your textbook readings. But this covers some important information for your test, and I'll highlight some essential pieces of knowledge to take with you. So we need to describe natural sources of carbon dioxide and particulates, and we'll learn a little bit more about particulates here. CO2 appears naturally in the atmosphere from sources such as respiration, decomposition, and volcanic eruptions. And there are a variety of natural resources of particulate matter as well. So, at the end of this, we're going to take a look at just a nice review of a scientific experiment as well. But there are a lot of natural sources of air pollutants. Lightning strikes actually convert nitrogen, atmospheric nitrogen, to our nitric oxides as well. Um, Forest fires, I mean, that's just plain combustion right there. So carbon monoxide, particulate matter from the ash and soot, and smoke, and nitric oxides as well. Remember, any combustion process will turn nitrogen into nitric oxides, NO1 or NO or NO2. Combustion of biomass will also release carbon dioxide, of course, and water vapor, which is a greenhouse gas, but we don't worry about it because it cycles out of the atmosphere quickly enough. We've talked about conifers, plants. They emit volatile organic compounds, terpenes and ethylene from pine, fir, and spruce trees. This forms a natural photochemical smog. So the Great Smoky Mountains are this way specifically for that reason. It's an interesting thing to see. And volcanoes themselves emit sulfur dioxides, particulate matter, carbon monoxide, and nitric oxides. And it's even said that sulfur droplets as well that are released from volcanoes have altered weather conditions such that they block sunlight and have caused winter-like conditions for even immense volcanic eruptions. So it's an interesting thing. Respiration, of course, will come up. Oxygen is converted to carbon dioxide through respiration. This is the reason that we have um, high biological oxygen demand during eutrophication is because bacteria require the process of respiration to break down material. We see oxygen being depleted from our waters now. In the air, that's not as big a problem. Natural particulate matter sources, sea salt actually, pollen, ash from forest fires and volcanoes, and dust. Windborne soil erosion, as you can see right here, wind erosion. This leads to haze, scattering of sunlight, and reduced visibility. And then we have our aerobic decomposition, which we convert oxygen into carbon dioxide, decomposition of organic matter by bacteria and decomposers in the presence of oxygen. This releases CO2. And then anaerobic decomposition, when we decompose things without oxygen in oxygen-free conditions, this actually releases methane. So it's not a source of CO2, but it is a source of carbon, which is also a greenhouse gas and quite a potent one as well. So here, particulate matter, these two, you're going to need to distinguish between these two, PM10 versus PM2.5. So as you read through, make sure and feel free to pause this at any time, by the way, and go back if you need. But particulate matter, solid or liquid particles, it can be liquid as well, suspended in air, also referred to as particulates. PM10 is less than 10 micrometers. These are droplets like dust, pollen, ash, or mold, and these are too small to be filtered out by nose hairs or tracheocilia. Can irritate the respiratory tracts and cause inflammation. So you have here grains of sand, and then you have, let's say, the average human hair, and then you have particulate matter, which is actually quite smaller than that. So this can travel, through your nose and through the trachea, and it can make its way into your lungs. And even smaller than that, PM 2.5. All right, which is quite worse. Anything less than 2.5 micrometers. From combustion, especially, right? We'll see the breakdown of a lot of chemicals, and we'll get small particulates from this. These are most likely to travel deep into the lungs, into your alveoli, due to their small size, and can be associated with chronic bronchitis and increased risk of lung cancer, especially because these particulates can carry other elements on them. If you're burning coal, remember you're releasing lead, mercury, and arsenic, and that travels on particulate matter, especially. So something to keep in mind. Here we have a practice FRQ, and I'll read through it. Students want to conduct an experiment to determine how road construction impacts the amount of particulate matter in the air. They spread Vaseline onto the bottom of 6 petri dishes and place them at various distances from a road construction site and an existing road. The first 3 dishes were placed 50, 100, and 200 yards from the road construction site. The second group of dishes were placed 50, 100, and 200 yards from an active road not under construction. Identify the control group used in this experiment. Well, that would be the Petri dishes. The second group at 50, 100, 200 yards from an active road which is not under construction, because we are investigating how road construction impacts particulate matter in the air. And so we need to see what it's like when there is no road construction. So that is our control. The dependent variable, the students are measuring, and describe how they can measure this variable. Well, you've got your dependent variable and your independent variable. Your dependent variable depends upon your independent variable. So they're seeing how road particulate matter in the air depends upon road construction. All right, so the dependent variable is your particulate matter, and they're measuring to see how much particulate matter is gathered in these petri dishes at specific distances from the road site. And this Vaseline will actually allow particulate matter to stick to the petri dish. And the idea being that I would suggest a hypothesis might be the closer the petri dish is to the road site, the more particulate matter you will gather in these petri dishes. And we'll see this decrease with distance from the road construction site. And there you go. Okay, so remember, go back if you need. Use this as a nice outline to prep yourself for taking notes and learning more. And we'll move on to 7.5 now.